Okay, let's just try the last two questions. 3 to the x plus 3 to the x plus 2 equals 10. Well, we see right here there's a common factor. We're supposed to solve for x. 3 to the x is in both, so we write it outside of a bracket like that. 3 to the x times 1 is 3 to the x. 3 to the x times 3 squared is 3 to the x plus 2. See? Write down the base, add the exponents. Ooh, but 1 plus 3 squared, that's 1 plus 9 is 10. Divide both sides by 10, we get 3x equals 1. And now the big trick is 1 is really 3 to the 0. Now I can compare the bases, and x must equal 0. And there you go. The next question is a little trickier. We're going to first put all the x's together. So we subtract that. We subtract 2 cubed, which is subtracting 8. We get minus 7 there. And I'm going to add it to this side and make 0 because this is going to turn into a quadratic. Not so easy to see right now, but that's what it is. Because if I multiply everything here by 2 to the x, watch what happens. 2 to the x times 2 to the x plus 1 is 2 times 2 to the 2x. 2 to the x times plus 7 is 7 times 2 to the x. Ooh, this is a quadratic thing happening here. Pretty strange. Now, 2 to the x times 2 to the minus x, that cancels. Just leaves me with 2 squared, which is minus 4. Now, this is like 2x squared plus 7x minus 4. I put two brackets, and look at this. 2 times 2 to the x times 2x, that gives me the first thing. Minus 4 times 1 gives me minus 4. And then watch this. 4 times 2 is 8. Times 2 to the 2x, minus one of them is the 7, so it works perfectly. Now the first one, if either of these equals 0, that's an answer. But I can never make this 0. This can never be a negative number, 2 to some power, so there's no solution here. But this one I can solve. I add 1, I divide by 2, 2 to the x equals a half, x must be equal to minus 1. There you go. That last one was pretty tricky.